Okay. First off, thank you all for coming. It's tremendous seeing you all here. Tori talked a little bit earlier today, but, we started this, I think of it as an adventure. Back in 2018, no one knew what DataOps was. So it's awesome to see you all here. It's awesome to think that this is our third event. It's awesome to think that next week I'll be in two different events in Europe that are also talking about DataOps. DataOps Days in Sweden, in Malmo, and I've done them in Denmark as well. So it's exciting. There's a lot going on, and we're going to talk about it here and talk. I did not have Sebastian's presentation or know what he was going to talk about before he did it, but you'll see a lot of overlap. And what I'm going to try and do is build another layer deeper. He had a lot more statistics because he's an analyst and he has access to that. And I'm going to go into more, hopefully, pragmatic what we're seeing in technology. I'm going to start off very broad. We're all very familiar with the technology ecosystem within a manufacturing company. And there's a lot of different technology there. And in many cases, this was all put in at different times. Many manufacturing plants have been in place for tens of years, if not hundreds. They have equipment that's at least tens of years old. They have technology that's, 5, 10, 15 years old. When it gets older than that, we really start to question them, but it does still exist as well. These sort of systems, they were put in place independently. You often have an individual or multiple, sometimes even teams, who in their title, they're the OT engineer for the MES system, or they're the MES administrator, or they're the historian administrator. These systems were put in place independently with their own teams. And there's, when you put it in place, there was how do we get the data into it? What data do we need to share with others? Barely. Mostly, how do we get the data into it so that the system could run? As Sebastian commented earlier today, this can't live as we move forward. This can't live in the age of Industry 4.0. It can't live in the age of agentic AI, which is where I fundamentally also believe we're going. Whether you call it, I call it 4.5, some people call it 5.0. We'll let that debate be had at the bar. But either way, it can't continue. We can't continue. We need to rethink things. And actually, Sebastian talked about this. We need to have a foundation, and that foundation is industrial data. Industrial data is what underpins all of those systems, and it's what connects all of those systems. So if you expect in our companies, our manufacturing companies, whether you're in pharma, whether you're in auto, whether you're in oil and gas, food and beverage, industrial equipment, if you expect to extract enterprise value and you expect to deliver value from AI and value from your cloud investments, you need to have a data strategy, and it needs to underpin all of this technology. So what you should be asking is, what is an industrial data strategy? And so, we think a lot about that, and how do we fit into that? Well, the first slide that I showed highlighted the fact that most companies came at this with an application strategy. For many, many years in the industrial space, we talk about ISA 95. That's kind of the high level. What is that? That's a layered application strategy. I believe that you need to go beyond that. Instead of having it based on applications, you need to start at the data. Start at the data, a data strategy. You define your scope, you define your governance. Depends on your company. Some companies are very centralized, some companies are decentralized. Either one can win, either one can be highly successful. You just need to define it, you need to know it, you need to work with it. You need to have your application strategy. It is absolutely critical. It is the connection to the people, to the humans, and it's the connection to the analytics and whatnot. But then you also have a storage strategy, and this is what the cloud vendors have brought us, that we've decoupled our applications from our storage. And so now we've also got this storage strategy. Are we storing on-prem? Are we using the cloud. We have to be using the cloud. The cloud is tremendous. And then we've got an integration strategy. And this is where Industrial DataOps comes into play. Within that, we've also got an architectural patterns, and we can think about those. And then we've got, of course, regulatory, and we've got security. So I think these are the components of an industrial data strategy. These are the things you think about as you're starting to look and bring all of these systems together and start to develop the strategy, which then drives success. So today I'm going to focus on industrial data ops. That's where we really focus. So then the question is, well, what is industrial data ops? So industrial data ops is about curating and delivering data. Data ops comes out of the IT space. When we started looking at it in 2018 and 19, the only companies talking about data ops were Hitachi and IBM. They had published a number of papers on it, and they talked about the need to curate data for analytics and for consumption. So in the industrial space, generally, we think of our factory has got lines. Inside a line, it's got machines, and inside a machine, it's got assets. And so we naturally tend to just model based on assets, actually. In many cases, especially in the process industry, we have assets. We need to think about, I forgot where I was going there, but we need to think broadly about data ops, and we need to think about the target. That's where I was going. So who's consuming this? The asset maintenance team loves assets. That's what they maintain. But the process team thinks about the line and the efficiency of the line. The quality team thinks about the product. And so we need to recognize that we need to curate data for the consumer, and that they start to drive how we're going to structure, how we're going to contextualize what the frequency of that data is. So that's really what data ops is. It's about curating and delivering data so that it can be rapidly consumed. It's not about doing the analytic or about doing the visualization or acting. It's about delivering the data. So data ops can be broken into 4 key pillars: orchestration, observability, quality, and governance. And we'll talk to those, but HighByte has built the HighByte Intelligence Hub to really meet those 4 key pillars. In the HighByte Intelligence Hub, it's a data hub. It can run on-premise. Generally, most of our customers have deployed it on-premise. It can also run in the cloud. There's nothing preventing that. Some customers are running both. Some customers are federating it. We'll talk even more about that later as we add more technology for that. But it's a data solution that allows you to move data efficiently across your mesh or across your application space, so you can effectively utilize data and move it around. It's really focused on standardizing that data. We heard about context. Context is critical. There's lots of definitions of that, but it's how do we curate that data for the target, how do we deliver it, and how do we do that at scale? It's all about scale. All of this stuff could be done manually for one asset or small amounts of data, but we don't live in that world anymore. The amount of data is only increasing, the sources, and so we need to do this at scale. And the consumers are also increasing. So the Intelligence Hub is really focused around that, and I'll get into more of that in just a second. To bring it back to those 4 key pillars, we've got orchestration. That's about moving the data, right? You need connections. You need to somehow pipeline or transform the data. You also need observability. Observability allows you to, we're in Boston. There's a lot of life sciences companies. There's a lot of life sciences companies here or people working in that field. You need to be able to observe the data. What's going, what's not, how can I fix it? How is it being transformed? How do I audit this process? How do I make sure that I can validate this? So we need observability. We need quality data. Quality is interesting in the industrial space. In the non-industrial space, you often have people typing in the wrong thing, and you're not really sure what it is or how to utilize that, or someone, abbreviates things. We don't have that problem in industry. What we have in industry with regards to quality are 2 key things. One of them is holes in our data. So we were collecting data, everything was going good, and all of a sudden there's a gap. There's a 2-week gap. It turns out someone changed a firewall, and we forgot about, and we didn't fix it on some connection, and we lost 2 weeks of data, and what do we do now? Well, do we have to scrap the product or not? And some companies actually have to do that. So you need highly consistent data. You also need to understand the data. So you need to make sure that you know exactly what the data is. And that's a key challenge with industrial data because it lacks context. Actually, Sebastian put up that slide that said the temperature is 350. And he said, geez, you don't know where that's from. You don't know the unit of measure. The reality is you often don't even know that it's the temperature. You have a number or some cryptic letter number sequence, and it's got 350 beside it. And there's one person in your organization that 5 years ago determined in the SCADA system that that's the temperature for that tank. So you need to add that context. So those are the two quality challenges primarily that we see in industrial. We see gaps in data that we need to solve, and we see data that we just don't know what it is. We need to add that context to the data. And then we need governance, especially as we're rolling out across the site and then across the entire enterprise. And in fact, I was having conversations with some of the folks earlier today, and it was about, well, they're actually using this to move data to their customers. Because in the pharmaceutical space, you have a CDMO needs to share the data with their customer. And so it's not just about your own enterprise, it's about how do we contextualize for our customer as well, or for our supply chain. So I'm going to break it down within Intelligence Hub. Let me jump back a slide. We deliver on all those with some key constructs. Connections, pipelines, namespaces, and models are the key contexts, and I'm going to break each one of those down. So connections, I think everyone's pretty familiar with industrial data, but most people, when they think about industrial data, they think telemetry. And I can tell you, having been in this industry now for 15, 16 years, it's more than just telemetry. Telemetry is core. Telemetry is the lifeblood of a lot of our core data, but you also have files, you have images that may be stored in the cloud that we need to bring down, images that need to go up to the cloud from a camera that took it, you have files that are created from inspection equipment, you have MES systems that have SQL databases, you've got ERP systems with REST APIs, you've got all of these, everyone talks about the protocol wars, and then I love the cloud vendors, but they all came in with their new SDKs, and then you have to figure out how to connect to all of those. So there's like multiple services. They each have their own approach to how to interact with them. So it's not just about one API or one protocol. There's multiple, and we live in this world that we just have to get used to that. So we need lots of connections, and we need the ability to move data across these systems. We also need to standardize data, and this is where we add context in what we call models. So models enable you to, number one, standardize the payload for a specific purpose, and then to add the context so that you know what the data is. And you add it into that data object, and then you deliver it. Key note, a lot of people are talking about graph and how can graph impact this, and AI wants to use graph. The key when you're moving data is to put the edges on the data so that when it lands, the graph can lay on top of it. So there again, it's not just about an individual data set's context. It's about being able to relate it to lots of other data sets, because that's where the magic happens. Next thing is namespaces. So we need to organize our data, right? Think about a bunch of data. You landed in a system. You've got data objects, and then you organize that data. And the key to being able to find data is, number one, is it organized in a way that I can find it, a logical representation. And this is where people talk about UNS and they talk about ISA 95, and that's a very logical manufacturing-based organizational structure. So you need to organize that data in a hierarchical approach, and then you put the data sets in it. So that's what namespaces are. And then finally, we have pipelines, and this is how data moves. So HighByte is the ability you can create these data pipelines. Fundamentally, our solution is a way of managing data pipelines. It's a solution that allows you to see all of your data movement and understand what data is going where, how is that data transforming? It's a sequential pipelining approach. And then what data went, what data didn't? Can we filter it out? Can we identify if bad data came in? What can we do with that? Can we send it to other targets? So an ability to handle all of that at the micro level of this data set changed in this way on this execution. And then at the macro level, these pipelines are running, these aren't, these connections are up, these are down. So you need all of that capability. And the last thing that's kind of baked into pipelines, but I think it's important to call out, and I'll also call this out because I love this slide because it was created, I think 3 years ago. Jeff created it, and he used an example of FedEx. And because we wanted to talk about cadence and data. And everyone can get their head around different packages have different sizes. And, some people are mailing a letter and other people are mailing a box of stuff. And some people have a lot of stuff in there. They're moving it around. And so when you're mailing things or you're moving things from one location to another, you may be working with FedEx. And as you can see, FedEx has lots of different modes that they can move stuff. They can fly it, they can truck it, they can van it. And each one of those has an inherent latency. Each one of those is buffering the information for a period of time and breaking it down. And each one of those has cost to it. I love this slide also because FedEx is our largest customer. And they presented at the presentation in Pittsburgh. So if anyone's interested in learning more about that, their distribution centers are doing predictive maintenance. But this really highlights the need for, sometimes with data, it's not just about moving a data point. Sometimes you have an event that you want to move data on. Sometimes at some common frequency, you want to move data. It may be very infrequent, once a day as opposed to once a second. You may want to buffer it for a period of time. If you're moving data to the cloud, the most efficient way to do that is to buffer it into a file and then land that in the data lake. In fact, we can even buffer it and then compress it in a Parquet file and then land it in the data lake, so it's most inexpensive. So, there's lots of different approaches, and then there are times when you actually don't even move it. You leave it where it is until it's needed. So we're going to wait until the request comes in and then we'll grab it. So it's very important because a lot of people, when they think about data, they just think, we'll just move it. Just hook it up and go. And when you start to get into adding context and all of that, and you get into the intricacies of it, it's very important to understand where you're moving it, why you're moving it, and the frequency. So I want to transition now into some design patterns, common design patterns that we see at HighByte. It's a lot of people talk about use cases. And my challenge with use cases is that there's literally thousands of them. But they use common design patterns. So instead of talking about specific use cases, we often talk about design patterns as just ways of moving data and how we can solve these to get people's kind of brains thinking broadly. So the first one I'll talk about is unified namespace. The concept is I can consume the data, I can structure it in a hierarchy, I can organize it, contextualize it, and then I can deliver it. So I can deliver it to an MQTT broker. If you've got clients that want to consume from that, that's the most common unified namespace. I can unify the namespace of a data lake. So S3 or Azure Blob or whatever, we can just unify that namespace. Snowflake, whatever you need to do, the key is we're unifying it and we're adding context to it. We can unify the namespace of an application. So that's kind of the most common design pattern. I'm going to collect a set of data and deliver it. We also see a lot of design patterns around files. So I never thought this would be such a big design pattern for us, but it's huge, and we're going to hear more about that this afternoon. But it turns out there's a lot of telemetry or a lot of inspection equipment that writes files, whether it's CMM files or just data sets or chromatography files, you name it. And then there's a lot of times you need to store those, especially in the pharma space, in the certain med device space. You need to store those for long-time traceability. And so being able to move files up into the cloud, being able to take files out of the cloud, being able to move imagery We did a presentation with Lindt Chocolate. They use our software to move images of racks of chocolate balls, Linder balls. They take a camera, takes an image of it, moves it up to the cloud. They run AI on it on the cloud, and then tell the operator which ones to pull out because they don't meet the quality standards. So lots of movement of files. Virtualization. This is where I talked about leave the data where it is and make it available when you need it. So we can virtualize. We can create a factory API layer effectively where we can virtualize all of the data from your historians, from your SCADA, from your MES system, and then just have one standardized API that your applications can consume from. And then we can do that against all sites, and so that's becoming a more and more common pattern for us. I want to dig in on historians and MES systems. So with a historian, we're also seeing a lot of patterns. We heard about that earlier today. We're pulling data from the historian and we're moving it up into Snowflake. And I think the pattern that we heard today was this backfilling concept of, I just want to pull all my data out of the historian and move it up into some sort of a data lake. But we also hear about we need to combine data from the historian with the MES, with the LIMS system or whatnot, combine that data and then move it up into the data lake or into some application, an AI application. We also hear where we need to land data in the historian. So we're often used to land data into Pi because, well, a lot of the development in Pi stopped about 10 years ago. So there's a lot of new technologies that people want to move data into Pi. It's not very easy, and so it's become a very interesting design pattern for us. But either way, we're doing a lot with historians, and if you use it, we can really put that data to use. Another common architectural pattern is an MES system. We're doing a lot more. So it can be about getting that telemetry data and standardizing it. We actually see this some with Tulip where if you can templatize those apps and then the data coming in, we can standardize that. It'll just fall right into the apps and everything will be beautiful. If you have to create a custom app for every single workstation, then it can be more painful to deploy and slower. So really about scaling out and accelerating MES transactions. Also, secondary equipment like label printers and things like that, we can move that data into the MES or into other systems. Analytics, a lot of people are pulling data out of MES so they can perform analytics on it, or just again, replicating it up into the cloud. We're seeing a lot of this where they're pulling out like all the metric tables and things like that, strip that out of the MES system, move it up to the cloud, and we'll perform analytics on it. So a lot of these kind of consistent user design patterns. I talked a lot about a single hub, and we put a lot of effort into what a single hub can do, but we also put a lot of thought and effort into what happens in the real world where you live in an enterprise, and how do we manage that across multiple sites, and even multiple hubs within a single site, and how do you manage things like we need to standardize the models, we need governance, we need to have dev, test, and prod. We heard about that earlier this morning. We do have some techniques on simulating data. If you ever need some, just give us a shout. But there's lots of need for multiple hubs. How do they interact? How can we see across them? How can we standardize configuration across them? Because that's really where the value is when you can roll these systems out. The key to FedEx's story is that they actually were able to roll out predictive maintenance across 40 different distribution centers in 6 months. And if you've been in this industry for very long, that's really fast. Really fast. We have customers that a year later are still rolling out in one plant. FedEx, they were very deliberate. They worked with an outside consultant, and were very focused, and they were able to do it. And they have a tremendous story, and now they're rolling out to another 60-something sites. So it's an exciting customer to work with. So, I always think of Intelligence Hub as a hub, right? Hub and spoke, and it's circular. And that's how it even got its name, because we thought of it as a hub. But at some level, we also think, in the IT world, we often think of layers of systems. So if you think your lower layer is the systems of record, you think of the what I've got labeled as storage and LLMs is kind of the hyperscalers. You've got your applications on top of that, your newer applications that are working that abstraction from the storage layer. And then Industrial DataOps really sits between them. So Industrial DataOps moves the data across the different systems of record, as well as up into that higher level systems. But it focuses on moving the data, not visualizing, not analyzing the data. So this is just another way of kind of thinking about how does it layer into my existing stack. Now, I do hear from some companies where they say, well, we don't want another layer. We're trying to get rid of layers. We're trying to reduce cost. And so then we kind of dig in and we start to ask a lot of questions. And what it comes out is they've got this layer. It's always there. It's always there. It's there today. The problem is it's fractured. You have no governance of it. You have no control over it. You have no visibility of it. It's just lots of little pieces of code running all over, right beside every other application that you've got going. It's Lambda functions up in AWS. It's, Python over beside or inside of Ignition, trying to curate that data. And you have, like I said, you have no governance, you have no control. So it's all about bringing a light to that so that you can scale it. This isn't about doing this because the old way was bad. It's about so that you can move faster. It's about the future and being able to move faster for Industry 4.0 or 4.5. So I'll finish this part of our discussion just talking about, again, why. Well, when I talk to customers, they talk about, and we actually have some new studies that we can share with you after this, but speed. It's about speed. One of the biggest bottlenecks that we see in implementing Industry 4.0, Industry 4.5, Industry 5, you name it, is speed, is OT and IT resources who know what they're doing, who can execute on these projects. And if we can make them 10x faster, then think about what you could do. Think about the projects that get shelved because either we don't have the people or the ROI doesn't quite make it. But if you could do it 10x faster, you look at Sebastian's slides and how challenging and costly integrations is. If we can do that 10x faster, then we can do a lot more. Then we can leverage this data, and then we can win. So it's about speed to deploy projects. It's about ease to maintain. It's about agility to be able to respond, try new technologies because technology is moving fast. We're going to see in a few minutes. We're going to hear about it, Amazon, then Aaron's going to show some demos of really fast-moving technology, but you need to be prepared. And really, in my eyes, that's what DataOps is going to give you. With that, I will take questions or invite others on stage. Any questions? What's that? One question.
Hello. Oh, there you go. So thanks for the presentation. It was great for me to learn, right? But I get this question a lot from different clients, and I sometimes have a difficulty kind of explaining to them. So I thought maybe I'd just go straight to the source, right? So, when does it make sense to introduce HighByte into an environment that has a lot of Ignition already?
You have to look at the use case. So the question is, what are their priority use cases? In some cases, they may have Ignition, but if they could get data out of their MES system and standardized and moved up into the cloud, then they can, they're not using Ignition for MES, they're using PASEX, or they're using Tulip, or they're using other stuff. I think it's use case driven. I think if they don't have any industrial automation going and they're just, I'll call them, they're pre-industry 3.0, they're just trying to get some basic visibility, they're probably not ready. Rick had asked earlier about large companies and small companies. And for the most part, we deal with large companies because they have sophisticated environments, because they've got 5, 10, 15, 20 applications that need access to industrial data, and we can enable that delivery of systems. The smaller the companies and the later adopters tend to have less infrastructure, less systems. They maybe run their entire business off of one MES/ERP business. Not so much, not a great target for us. So, we have to look at the sophistication of their environment. We have to look at what sort of use cases they're trying to implement, how we can help them out. But we do have some small customers, a couple $100 million in revenue customers who are doing phenomenal things. Most of those companies tend to be digital native. So companies that were created in the last 10 years, and the entire team is very digital centric. They want data. It's a very tends to be a younger team who's very aggressive and needs data to do their job and recognizes the value. In which case, they're deploying us right at the beginning, because they'll skip ignition. They'll just drive that data up into the cloud and then start running ML on it and analytics on it. And then at some point, they'll get back to deploying some operator terminals. They're just using the standard stuff that comes with the equipment. So it varies.
Okay, so I would say my main takeaway, so when I explain it to other people, would be the sophisticated environment, right? So it's not just based purely off size, but like you just said, the digital native companies, they know where they're going, and it's like why do a pit stop when you know exactly like what the roadmap looks like?
So industrial DataOps is about moving industrial data and contextualizing it. If all you're doing is moving some telemetry into ignition, and that's the extent of what you're doing, then you don't need industrial DataOps on top of that. If, on the other hand, you're trying to leverage the cloud, leverage AI, you've got an MES system, you've got a CMMS system, you've got a quality team that needs access to data, and they're not using ignition, then industrial DataOps. And in fact, we have multiple mutual customers with ignition, as well as customers that have started with us, and of course many that have started with ignition and then moved into us. Yep. Thank you. Great question. Oh, I got more.
We got one. All right.
I'll talk quicker. I'll answer questions briefer.
Yeah. So on that note, if you were starting a factory today, planning 100 million, 200, 500 billion dollar run rates eventually, would you put, honestly, I certainly see the use of HighByte in the legacy systems connecting everything together, but if you were digital native, wouldn't you maybe skip HighByte altogether? I don't know if it's a politically incorrect question here, but because you do ultimately, you want to talk to your equipment, you spec all that out. You have some platforms that just do a little more. You do the one thing very, very, very well. But if you're not planning on implementing 20 legacy systems, do you wait 30 years until you've got a bunch of mess of different systems and ideas and then get HighByte? But it's not in your roadmap.
No, because the key is like the future where we're going is persona-based solutions, meaning you're an operator on the shop floor, you're using Tulip. You're a maintenance team, you're using a maintenance application, you're using MaintainX. You're a data scientist, you're working in the cloud. So I think we will, for many years, have multiple applications to run a factory. You're purchasing equipment. A lot of people actually skip ignition because they buy the equipment has the panels on board. They don't need a central location. They just start moving the data up into the cloud and they're going. So I think you have to look at what is our application strategy? How do we want to think about that? How do we want to deliver data to our functional teams? And then if you're spanning multiple applications, you need some way of integrating those and having visibility over that data. And even beyond that, like I talked earlier, like files. There's loads of files moving around. There's CAD files coming out of the cloud. There's imagery going up to, like all of that sort of stuff. You're still moving data. And so that's all industrial DataOps. It's not just about the telemetry visibility. Rick, were you going to add to my answer or ask another question?
I'm guilty of creating some of the things that people bastardized into industrial DataOps solutions. So I think it's the difference between a purpose-built application for that with particularly a digital native company understanding the importance of governance, version management, all those kinds of things that, we didn't think about DevOps 10 years ago as an integral part of industrial automation systems. So those aspects, plus a purpose-built solution that a systems integrator can come implement. Someone joins the company. They're looking at an application designed for moving data as opposed to a tool that might have scripting or coding capabilities that lets you do it. Meaning, you can make almost anything do anything. It's a question of how maintainable it is and how purpose-built. So I think that's kind of another interesting dimension. Is it purpose-built and maintainable? And you know what? There's perfectly good situations where the use case would justify just a relatively simple solution and some scripts. But I think sophistication is one element, but I think long-term maintainability, governability, all that kind of stuff matters quite a bit.
Thank you.
Yeah. Thank you, John.